Studio. So the problem I'm telling, the first problem is maximum sum survey of size k. Now just write it down. Maximum sum survey of size k. Now you must know what is a survey and what is a subsequence, right? So sub, you are listening, right?
Yes.
So sub array is a contiguous elements of numbers, means elements
Mm-hmm.
in the array, and subsequence is not means it's not always contiguous. It can be any combination of numbers in the array. So
Mm-hmm.
sub array, when I say, it is always in sequence, and
Mm-hmm.
sub-array means one after another. There will be no break.
Mm-hmm.
It is always it's contiguous.
Mm-hmm.
Subsequence is different. Subsequence is not contiguous. It's
Mm-hmm.
a part. It's, let's say, one part of array and another part of array. So you combine two parts of array, but
Mm-hmm.
it's not contiguous. So today we will solve sub arrays. And when I say sub arrays, and its size of something, you are finding a desired output, let's say target sum or something called
Mm-hmm.
size of k size subarray, then your mind should hit, like your mind means the logic you have to first come up with. Can it be a sliding window problem? Can we solve this problem using sliding? But always we'll start solving with brute force, then optimization comes. And in the interviews as well, you have to start with brute force and then optimize solution. I-
Right.
if you have to share, then
Mm-hmm.
the chances to get the job will be increased. So
Mm-hmm.
now the problem is maximum sum survey of size k. Now the
Mm-hmm.
problem statement is very important, so read the problem statement and as well as write. Given an array of positive numbers, it's very important. Given an array of positive numbers, only positive,
Mm-hmm.
and a number, also number, integer number, positive integer number k. K is a variable number, means you can assign k as any integer value. Find the maximum sub of any subarray of size k. Means you have to find the maximum sum of subarray of size k.
And the maximum of any sub array of this. Okay.
So you have given an array. Let's say the
Mm-hmm.
array, take an example array as 2 1 5 1 3 2 1 3 2, and k, let's take as what, 9, sorry, 3. So you have to take three length of subarrays here. What is the first
Mm-hmm.
three length subarray here? 215, right?
215. Yeah.
You have to sum up all these numbers,
Mm-hmm.
and in the next subarray, what will be the next subarray?
151.
Yes. So three length
Mm-hmm.
subarray. So you have to take, or miss, you have to gather all the sums, and you have to give the output as which is the maximum sum of
Mm-hmm.
subarrays present in this.
Mm-hmm.
So if you dry run with this, means this example, what will be the output?
If I do what?
Means dry run means, for this example, just calculate
Uh,
what will be the output.
so
Not
we want the we find the maximum. So 215. Five. It's 8. 151 is less. Then 513 is 9. 132. 513 will be the answer
Hi.
for the maximum sum of subarray of size k.
yes, 513. That means the output should be 9, right?
Yes.
Hmm.
The output we have to give the
Yeah,
sum
first
or
solution.
the.
Yeah, see, there are many variations. First, we will share the output of the sum. Next, we will solve the printing the subarray, and uh,
Mhm.
and various other questions will come. But the
Okay.
first question is you have to re- return the sum of that subarray. Okay, that's very easy. Now,
Okay.
what will be the naive approach to solve this? So naive approach will be, or
Mm.
precisely, you have to start, means what is it? You have to take
Yeah.
variable.
Can I say? Yeah.
Yeah, tell me.
So let me see. So yeah, we'll take two variables, two loops, I mean.
Hmm.
So the first loop will be for I less than array dot length I plus plus, and then the second loop will be j less than k. J equals to I and j less than k, right?
Means can
J
you tell
plus.
me the logic only?
So basically, I first I take the first element
Hmm.
and then go up to the third element from there. So basically, I would do two. My sum will be two, and then my sum will be two plus one. Then my sum will be two plus one plus five.
Hmm. Hmm. This is the
And then
yeah first subarray.
yes, yes, and then so now we are out of that second loop because we have reached three.
Hmm.
Then j equals to uh, two.
Hmm.
And so basically j equals to I and j less than will be 0, 1, 2, 3. So sorry, j less than I plus k actually,
Hmm.
right?
Yeah.
Because we don't want to go further. And then yeah, again we'll check. Um, then if the max sum, but we keep condition if max sum is after we so in the second loop after we are done getting the uh, sum sum equals to uh,
Open this doc I have shared in the chat. And
Google's yeah, yeah, I can open.
yeah, just open it. So share this that screen only. Ah, okay. And copy
Oh,
this everything there.
next will be 1, then 1 plus 5, 5 plus 1 6, and then check if that sum is greater than the max sum which we calculate, which will be the most recent sum. Then we update the max sum to that sum. If not, we just keep going until the until I reaches the end of the array.
Yeah. So basically, what we are doing here, we are for this example, 2 1 5 1 3 1 3 2, we are taking 1 minute. Yeah. So for this array, so 2 1 5, this is our
Mm-hmm.
first subarray. So I sum up all the elements in this subarray and we just store somewhere, right? So we keep a pointer of starting element of every subarrays, and from that element we are taking next k elements, and like that we are doing using two nested loops. We are solving for all the subarrays present for this array having the element of subarray length of size k. So
Mm-hmm.
how do you solve this? So first you have to take one for loop, any loop which will traverse n minus k elements from the first array.
Mm-hmm.
So can you write the pseudocode? Try to write.
Um,
So let's say I am giving you the function. Just wait.
Mhm.
Oh, shit. Yeah.
So we are doing the optimized method,
No,
right?
no, no. This is the brute force one. So how do you solve this using two for loops? Basically, here we are taking every two means every case size array. So
Okay.
just brute force one. So you have to take a max sum variable which stores the sum of such every possible subarray and take the max, and yeah, and and window sum as well. So for
Okay.
n less than k, yeah, n is the
And
size
its
of, yeah,
length.
length of the
Mhm.
array.
Mhm. J less than zero. Less than zero plus three.
J starts from every
Okay.
just wait. J starts from, or I is basically what? I is starting of every possible subarrays.
Mm-hmm.
So J
Mm-hmm.
starts from that I till I plus k,
Mm-hmm. Yep.
and we are taking the sum. Let's say window sum. Let's say the variable name, and we are summing up all array of J. Basically, there sum plus equal you can do. Yeah. Huh. And after this loop you just take the max of every possible subarrays.
If done.
So you can use math dot max as well, or if also, both. I prefer math
Mm-hmm.
dot max one.
Oh, okay.
If max sum is greater
If the sum is greater than
sum
max
is
sum.
greater than max sum, then update the max sum.
Mm.
Uh, yeah. So another two, a return maximum. Two things you have to update at line number, line is not there. Before starting the for inner for loop, you have to update the sum means uh, what I say, reset the sum variable basically, sum to zero. For the next sub array we start from zero, right? And not here, in the next line, yeah, here. For every sub array basically we take.
It will be different. Yeah.
So yeah, now Sabare, and this should be plus one basically. This is just simple logic. You just check. So here in the image you can see 215 is the first Sabare. Next Sabare is
Mm-hmm.
151.
Mm-hmm.
So here I basically starts from 2, and J I is 2. 2 means index 0, and J is I plus 3. K is basically 3. I plus 3 means 0, or I plus 3. Basically if you find I plus I minus just wait. Yeah, so I plus 3, basically I plus 2 we are taking index wise. So 215. So this is the inner loop. It's running from 0 to basically 3. Less than 3 means 2. 0 to 2 it's running. So
Mm-hmm.
such way you are finding every possible sums. So the beginning of every subarray is I, and from that we are in the inner loop we are taking every such possible subarrays.
Mm-hmm.
If you carefully observe this image, it is basically a classic sliding window problem. How? We are summing up the first slide. Slides means here the subarrays. Basically, we are taking a slides. So we are taking a slide of first subarray. We sum up that subarray slide. Then after for the next slide, what we will do? We add one element at from the end and remove one element from the beginning. For the next, go to the third line. What it is doing?
Mm-hmm.
Two we removed. I cannot even. There is no annotation is there. Okay, so two we remove. Okay, I can do two we remove and add one in it. You can see it, right? Go to the image. Yeah,
Yes.
two we remove and add
Mm-hmm.
one in it. So
Mm-hmm.
you cannot see the annotation, I think. Okay, so this
Got
is
it.
the next slide, basically 151, where we added one, and for the next slide as well
Mm-hmm.
we remove one. Two means
Mm-hmm.
one means starting of that means previous slide, starting of the previous slide, which is one, and adding three in. So like that we are doing for every such subarrays, or you can say slides. So
Mm-hmm.
yeah, so for this, what's okay, what is the time complexity for the first approach?
Um, O of n square.
O of n square is general terms, you can say, but yeah,
O
for
of
more specifically,
O of n O of
how many
n
times the,
into O of
yeah, just hold on, how many times the first slide first loop will execute, how many times?
O of n minus k.
Yeah, order of O of n minus k, and the next slide
O of k.
O of k, that means k into O of, just write it down, O of time complexity is O of n minus k into k into k. That means if k becomes n, or let's say k becomes n by 2, or such number, then this time complexity will be n square, quadratic time. Then you can say
Right.
depends upon the size of k can be 1 as well, then it's linear, but if worst case it is on n square, depends upon the
Mm-hmm.
size of k. But the next approach, it's linear time. We are using a single pass solution, or you can say two pass solution, based upon some it depends upon the preference of the developer, but two pass
Mm-hmm.
is more you can intuitive to solve. So the first pass, yeah, that's it. Yeah, so now what you have to do, for the first pass you have to sum up the first initial slide. So can you start right for the first slide, sorry, first subarray or slide, what will be code? So for, let's say, the same function given to you, you're following, right? I have written down.
Yes. Yes.
Hmm.
So you're saying like using two pointers.
Two pointers I am not saying, two passes I am saying.
Or just like you're saying like adding and
Adding
removing
one
the.
element in it and removing one element in it. So for the first pass, for the first pass means basically loop. Yeah. Pass means loops.
Mm-hmm.
You can find in many places. Passes basically the loops.
Mm-hmm.
Okay, for the first pass, you have to sum up all the first k elements. First k element. So run a loop till k and sum up all the k first k elements in it. Run a loop, then you can understand yourself what we are doing. I less than k, I plus plus. So it is the first 215 basically, first pass, first subarray.
Mm-hmm.
Let's say sum equals sum, yeah, sum array of I. Hmm. Array of I. Yeah. For the next pass, start from k itself. So let's say it's basically int of, let's say j. Let's say for the next pass, for the next loop basically. Yeah, you are writing or I should?
Hello.
Yeah, you are listening. You are hearing.
Yes, your voice got cut off before. Yeah, yeah.
Okay. For the next pass, so for the next pass, let's say for j, this starts from k, right? Means what we are doing, we have sum up 215 and store this in some variable. And for the next pass, we are starting from k means what? K means 3, right? So we are starting from 1. 1 means which one? The second one. 2151, right? That one.
Mm-hmm.
That one we are starting, and we are, how many times this loop will execute? It is till the end. In g plus plus. And what we are doing here, and basically we, let's say, take another variable. Let me write it, then you can understand. So let's say current sum is, we store in, basically in current
Mm-hmm.
sum. And what we will do here, so current sum equal current sum plus ARR of, but which element we have to add? ARR of I. ARR
Mm-hmm.
of, sorry, here is J, and we have to remove ARR of J minus K, the last element, right? And you
But
have,
J is starting from K. K is 3.
K is 3. Just write,
So,
let me write it once again. And
yeah.
let's
So where did the
see,
second element go?
wait a minute. So, and we are basically current, and you just return this sum. Basically, here you can take sum and you return the sum. Yeah, now ask me your doubts.
So you said for in J equals to K, so J equals to 3.
Hmm.
3 less than 1, 2, 3, 4, 6. 3 plus plus.
Which one? Yeah, it starts from 3. Means J is 3. 3 means what here in the image? 2151. 1, right? 1. Second one after 5, right?
Yes.
So current sum, we have a sum with us, right? We have a
Mm-hmm.
sum with us, and
Mm-hmm.
that sum we store in current sum,
Mm-hmm.
right? And we are basically update, we are adding the array of j is basically what?
Go.
1. So if I write here,
0. J is 3,
hmm,
right?
so what we are doing here, for the first array, what we have done for the first pass, basically not first sub array. Yeah,
So you are
2
saying you're calculating
5.
215
And for the next one, 21215 I have with me. I
And you're
added
calculating
1,
2151 then,
1,
and then removing 2.
removing 2 from it. J minus K is basically the
Mm-hmm.
beginning of the previous slide. And this gives me for the current slide, current sum of that slide, current slide, I can say. And every time I am just comparing math.max, you have done with if block, the same I prefer to use math.max, is
Mm.
one liner. So I just calculate which sum is greater,
Oh, okay.
and
Got
I
it.
store in the sum and return
Mm-hmm.
the sum here. We say return sum.
Mm.
It's a pseudocode. uh, okay, so you understand, can you tell me what we again, can you repeat what we are doing here?
So the first thing, you're just calculating the first elements of the first k
Hmm.
uh, sum,
Hmm.
first k elements sum
Hmm.
separately, and then you are just starting from the kth element in the other separate loop, and then you are just gradually removing the j minus k elements sum and adding
I am
the
adding one from end at the end and removing another from the
j minus,
beginning,
yes. So
right?
yeah.
So this is two pass. Two pass means what? Pass means I just told you.
Yeah.
Pass means pass means
Two
basically
loops
loops. It can be done in
separate.
one loops as well. Uh, but I
Mhm.
prefer to for you use two loops. There is a one loop
Mhm.
solution. This you can also refer, but it's better, right? For two loops, you understand it
Mm.
properly. This is
I mean, it's the same time complexity, right?
time complexity wise same, yeah.
Yeah.
But the pattern, I say that some developers write different ways. So, but both are
Mm.
work fine. Now, what is the time complexity here? First loop runs for order of k time, and second one
Mhm.
runs n minus k times. So basically, it's order of
Mm.
n, right? Just write it
Mm.
down. The time complexity
Order of
k
first
plus
loop, order of k. Second loop, order of
n minus k.
n minus k. So how is it order of n?
In worst
Oh, you
case,
add it. Order of n minus
yeah,
k plus
n
order of k.
k
It's,
plus, yeah, n minus k. So in worst
mm,
case, it's order of n. Depends upon the size of again k.
mm,
K can be, let's say, n by 2. So in that case, it's the
mm,
previous one we are here we are summing, but previous one we are multiplying. So that's the
mm.
difference. Now
Okay.
some yeah, yeah, you understand till now, right? If you
Mm,
understand, I am giving you one variation of this question, little variation. The
mm,
question, write it, write the question down.
mhm.
Given a array of positive numbers and the size means same, like that input is given same, you have to find if there is such subarray of size k with given sum. You have a sum given to you, target sum. You have to tell.
Hello?
Yeah, you can hear me.
Hello?
Yeah, I can hear
I
you.
couldn't after sub array of size k.
Okay,
Hello?
let me repeat it. You can hear me.
Yes.
Yeah, so you have to find if there is a subarray of size k with given sum, with given sum, write it down. With given sum means there is a target is given to you, which you have to find with given sum. Given sum, you can, in bracket E, you can write target sum. Target number is there. Yeah.
Mm-hmm.
Now basically inputs are same. You have to find if there is a subarray of size k with given sum. Code is like let's say 2 3 liner difference. The last code we have done means same, I can say,
Mm-hmm.
both the codes. Can you tell me what is means which lines, which statements you need to just update?
So basically, we need to return the array instead of the sum, right? The sub array.
You return just boolean for now, true or false. If there is a subarray of size, sorry, if the subarray having the sum present, you return true or else false. Make
Oh,
it
okay.
simple.
Um. So in the so what is the sum? Say sum is 9. We had, right?
Yeah, let's say 9. Yeah.
Target.
Hmm.
So in here for nj equals to k, j less than nj plus plus. I do cur sum equals to cur sum plus ar of j, and then I check if that every time I check there if that sum no after the loop is complete I check before returning the sum if that sum equals to the target.
Yeah, just copy your code here,
Mm-hmm.
whatever you have done previously, and update the statements, instructions.
Okay.
Then I
Yeah,
can
me do
understand.
from here.
Let me copy it for you.
Mhm.
You are understanding, right? This is very easy problems. These are very easy. There are more complex problems are coming later on. But you have to understand these easy problems first.
Yes. So if here I'll check if sum equals.
No, this one. So take the sliding window. This is the brute force, right? Let's
Yeah,
see.
I was doing for both.
Okay, okay, fine. Once you do, hmm, right. So you are taking, you are comparing, and if it is there, you return true or else false.
Right?
Hmm. Yeah, that's it. So you're just
Mm,
for every time you're summing up, and for sliding window, how do you solve this?
yeah. Yes, I'm copying it. So here is sum equals to math.max sum or sum. Okay, yeah.
You just
So
remove
for
this line.
nj equals to k, sum equals to this, and then I check if
If that
yeah,
sum basically equal target current sum, here you current sum.
current sum. Yeah.
Yeah, for here as well you have to check basically for the first uh, pass as well, because you are doing from the next pass. For the first pass as well you have to check.
Oh, so then you don't have to do the next pass itself.
Yeah, you just return from there. Let's say you got in the first slide itself your desired
Mm,
target. Hmm? It can be more optimized, but yeah, that's fine. Means you can simplify these lines, but yeah, this is the logic. Fine.
Mm.
This is the what is it? Standard sliding problem.
Mm.
It's fixed sliding window. There is a variable
Mm.
sliding window we'll discuss next. Now write the
Mm.
next problem. The problem statement is given a unsorted array of non-negative integers. Write it down. Given an unsorted array of non-negative integers,
Mhm.
find a subarray with given sum.
Mhm.
What's the difference between these two questions?
Given an unsorted array of non-negative, find a sub-array with given sum and given an array of positive numbers.
Just go through the last and means both the previous question and current question. What do you think? What's the difference in these two questions? What is missing, or what we have added in it extra?
So in here we don't have k. We don't have the slide like the k window
Yeah,
predefined, right?
predefined. So that k can be
In,
anything right now.
yes, yes.
As in the last problem, it is given to you the size of k that the slide or say subarray is fixed length always k. But for this problem, the size or slide will be variable or
Mm-hmm.
variable in runtime depend upon means the logic based upon the logic to find the sum target
Mm-hmm.
sum. So you can make a slide of let's say 5, sometimes 3, sometimes 9
Mm-hmm.
or 2 based upon to find the based upon the logic which you need to execute.
Yes,
This is called variable slide. First one was fixed length slide.
yes.
Hmm? Now, now you have to write
Mm.
the brute force. What is the brute force? First, think about that.
So let's see, we have same two, one,
Same number, yeah. But the sum is
five, 215. What was next? 132. So find a subarray with what's the sum?
what is the sum? Let's say 9.
So basically, I go start with I loop, I less than the whole length of the array n I plus plus. Then I do j equals to
Just write it down.
I.
Yeah, we'll then discuss. Write it down, the loops. So first loop will two nested loops will do. One loop, yeah, execute traverse whole array, and from the next loop, how it works. Yeah, tell me. Simple two four lines. J for my yeah, J less than
J less than.
n.
Mhm.
Here we are finding out all possible subarrays we are getting gathering. All
Mhm.
possible subarrays can be present.
So ARR of I. Oh no, ARR of I will be here. Sorry. Some
Yeah, you reset the sum. You can
I
reset
and then
to zero as well. Sum you can reset. No,
and then I add ARR of
I'm
I
saying
plus J,
here
and then I keep adding ARR of J. If sum
equal target.
equals target on true. No, find a sub array with a given sum.
For now,
Find
you just return true or false. We can
oh
then that is your homework.
okay.
What is the time complexity?
This will be O of n squared because the both cases we are traversing through n.
For all possible subarrays starting from
Yeah.
I. Starting from I, we are traversing all possible such subarrays.
Yes.
We have to optimize it, and this is a I. Okay, today we will not solving the. I will give you some more clarity what is sliding and what is prefix sum. Sliding
Mm.
window problems. Always remember, sliding window problems will not work if there is positive and negative both for variable slides. For
Mhm.
variable slide window, if there is both means combination of positive and negative elements inside an array,
Mm.
then sliding window will fail. Then you have to use prefix sum with hashing. Prefix sum mostly use hashing.
Mm.
Hmm? Use prefix sum here. That is the reason given that there is no negative integers or no positive integers, either negative or positive. That's why you can use
Mhm.
sliding window. Else
Mhm.
sliding window will not be used. And what other cases sliding window will not use? If there is subsequence, then sliding window will not use, cannot be used, because sliding window
Mm.
always use on subarrays, not subsequences.
Okay. So it will be used. It will be useful in subarrays, not subsequences.
Subsequences, it will never you can think about the sliding window. Then you have to sort this array in subsequences. Subsequences problem also will solve, like longest
Subsequences are what?
just
What do you mean
read.
by subsequence?
Subsequences means just read one problem statement. It's your homework. Longest common subsequence is very common problem. Longest increasing subsequences. Longest common. We will discuss that later. This is kind of, there are many ways we
Mhm.
can do DP problem. Basically, these kinds. You are storing the variables. So
Mhm.
longest common subsequence LCS and LIS. We say LIS, longest increasing subsequence. This is LCS and there is one
Mhm.
LIS.
Okay. I don't know dynamic
We
programming,
will
so I
discuss
just
those
do
later when we
it.
solve
Mhm.
sliding subsequence.
But I can do it normally now, right? Longest common subsequence.
Yeah, for now you can do.
Mhm.
For now, another thing I want to mention for the last two problems, what are the edge cases? We did not discuss that. What the edge cases? You have given three inputs. What will be the edge case to first check if those inputs are valid? Like these are very important in interviews. They ask like what are the
Uh,
edge cases. K is given, target is given, one array is given. What the edge cases to check? These are the valid inputs.
like if I equals to k, if if the length of the array equals to k,
Hmm.
we didn't check that if arr dot length equals to k itself, then then also we
we
don't
just
need
yeah,
to go.
we can simply return that sum. No, 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 that
Yes.
will, in this logic, it will pass. But the thing is that if the array size is less than k,
Mm.
then this algorithm, this your logic will not execute.
Yes.
Array length should be at least k or greater than k. This is one
Mm-hmm.
condition. Then array
Mm.
cannot be empty, array cannot be null. Then
Yes.
let's say k cannot be empty, means k is not zero, non-zero. K cannot be zero. K is a valid, k is a valid input, valid positive input. These are the edge cases. Sum, when I say target sum, target sum cannot be,
Mm.
target sum can be zero. No, no, just wait. Target sum cannot be zero because it's given that array is always, target sum can be zero because let's say your array contains all zeros, then target sum is zero.
Mm.
Maybe zero. So target sum can be zero.
Okay. I think it's. Can you extend a few minutes?
Yeah, yeah, let me check.
Okay. So array less than and target sum can be zero, right? That is fine. You
Target
said.
sum can or cannot be zero, I think so. Just think about that, which cases
Mm.
target sum can be zero. Like you have to explain in the to the interviews interviewers, right?
I mean, if there are there is no such thing that the uh uh indeed like the array integers are not the same. Like what if there is zero,
If
zero, zero? That is possible, right?
array may contain, because it's a integer, zero is
Yeah.
a integer, so target sum may
Hmm.
be zero. But
Yeah.
if the array, if it's given that array does not contain zero, all starts with
Mm.
one always,
Mm.
then target sum is zero is means useless. You can
Mm.
simply like tell that if array does not contain zero, then why target sum
Mhm.
can be zero?
Right.
It return false. It can, you
Okay.
can, like it can be zero, cannot be zero, but so you can tell that, tell them during
Mhm.
interviews. But yeah, you should not mention the target sum in that case, means
Mhm.
zero or non-zero. Yeah, these tools are
Okay.
valid in conditions, edge
And
case.
what else is my homework then?
Your homework is for the two problems: find the sub-arrays, sorry, print the sub-arrays and size of the for the variable length. No, we did not discuss about, yeah, print the sub-array. For these two problems, print the sub-arrays. For the last problem, we have not discussed the optimized version. This
Mm.
I will share the template in the next day. There is a template, and 10 problem 10 15 problems can be solved using the template for the next
Mhm.
variable study. But for these two, whatever we have done, just understand those concepts, solve multiple times.
So, which one should I do? The optimized one for the last one we
Last
did?
one we will discuss in the next class, because there is a template. I need to discuss about the
Okay.
template.
So the homework is printing the sub-array for the previous problems and the longest common subsequence. That's that.
Longest common subsequence you can read, LCS, and
Okay.
there is a LIS, longest increasing subsequence. Because as you
So
told,
any other problem or just that? Just that
let
only
me
this.
share the problem statement. I think it's in late code. Yeah.
No, like do you have any other homework problems for the similar ones which we did today?
No, for now you try to solve multiple times, because these problems is very means building block, I can say.
Okay.
Next, we these are easy problems. Medium
Mm.
problem we will solve after that. So you should be clear about this concept. You should
Mm.
not have any doubts
Mm.
whatever we have done. Otherwise, next problem, let's say maximum, those are hard as well. Maximum
Mm.
sub array, something like, let's, I have to find the problems. Yeah, next day we will discuss the hard and medium questions,
Okay.
and the this optimized one, which we have done using brute force.
Okay.
Okay, this is
Okay.
your
Cool.
homework. Yeah, and this is the problem statement for longest common subsequence. You can read it for now. We will solve it later. Okay, this is a
Okay.
different concept itself. When I say sliding, it's always Savere. So we'll solve Saveres first. Slide subsequence we will not consider concentrate now. Okay.
Okay. Okay. Cool. Okay. Cool. And regarding the tuition fees.